In my previous video, I talked about how easy it is to do a simple thing like calibrating a temperature transmitter. And I thought I should quickly show you the results of the simple wiring that I showed you. So on the 227 from Additel, in the bottom screen, I'm simulating a RTD, a PT100, a PT100 385, which is the common style. And in the top screen, I'm measuring loop current. And we can see at 0 degrees C, we're at 3.994 milliamps as near as damn it. I'm using a simple in-the-head Novus transmitter. So there's a number of ways you can use the 227 to do this task. One would be to manually type in a temperature. So let's go to 50 degrees C, give it a couple of seconds to respond, and we get 12 milliamps, the halfway point of 4 to 20 milliamps, as one would expect. And we can manually step it through. There's a number of things we can do. But one of the features I really like about the 227 is the ability to set up tasks, something that I facetiously call apprentice mode, because it's very, very simple to make a task and tell the junior to go out and perform task 3 on every temperature transmitter you come across. So let me quickly demonstrate that to you. So if we go into the menu and we set up a task, I'll delete the task that's there just make it simple. Okay, let's make a new task. And we have a choice: pressure, temperature, loop, flow. So we're going to select temperature, and we're going to select temperature transmitter. The name, the serial number. Okay, so we'll call it 1, 2, 3, 4, 5, and we'll call it linked in 1. It's a model, doesn't matter, we'll call it a random thing. We're going to say that it's a 3-wire PT100. The output is going to be 4 to 20 milliamps, linear. The accuracy, let's say it's 2.5%. I can't remember what the accuracy is on this model. And then we'll save that task. And there it is. So you could say, apprentice, please go and do the LinkedIn 1 task on each transmitter that you find. So we'll select it. He'd put in the data, he or she would put in that data, and we'll go, let me just check something a minute, start. Now, you can have as many as 12 calibration points or set points and as few as 2. 5 is the default, and so what it's done over the 0 to 100 degree range, it's evenly divided those out. But if you were, say, in the milk industry, you could easily manually overwrite those. So we could say, let's make that 72 degrees C for pasteurization. And we're going to say the loop current is on because we're powered on the desk. We're going to do a round trip up and down, and we're going to do a 5-second pause at each point. Let's begin the calibration. Now, because we have feedback in this setup, with the 4 to 20 is being read by the instrument, I can hit automatic, and I can go begin. Sorry, it's already doing it. So first of all, we get a graph. We see that we have a rising temperature. So we have quite a big error at that second point. Now we're very, very flat up the top, so I'll have to check the programming on this transmitter. I suspect it's not set up as a PT100 as I suspected it should have been. Now we've got the falling, see the arrow pointing down, so we're going to see if there's any hysteresis on the way down. Now all of a sudden we have corrected that error at the midpoint. And we get a graph. At least we get a CSV exportable table at the end. So the tolerance was 2.5%. The maximum error we actually got was 25.01% with quite a lot of hysteresis. And there we have the CSV data that we could very easily export and swap between the graph and the CSV data. So you can see how powerful that feature is.